So I'm Michael. I work on the speed metrics team, and I'd like to talk about measuring responsiveness on the web. So on the agenda, just quickly, I wanted to cover a summary. Hopefully many of you have heard of this new metric, interaction to next paint, or INP, but I figure for this large of an audience, we might as well review it. And then I'm hoping to spend the majority of the time in a live demo with audience participation. We'll talk a bit more about that in a sec. All right, so interaction to next paint, or INP for short, is a new responsiveness metric, and it is designed with the goal of eventually replacing first input delay as a core web vital. So interaction to next paint, what is an interaction? We are measuring discrete user inputs. So taps on a touch screen, keyboard usage, or physical mouse. We are not measuring continuous input like scrolling or mouse over, hover effects, that sort of thing. We're still calling INP an experimental metric as it rolls out. And we get lots of questions about what does that mean? What does it mean for it to be experimental? Are you just trying this out? I'd like you to think about it more as a release candidate at this point than a sort of early alpha or beta. So what does INP actually measure? So it measures two things in that it's different from first input delay. The first is that it measures all interactions with a page. And the second is that it measures the full duration from the input timestamp until the presentation time of the animation frame that had the contents of the next paint that followed the event handlers. Okay, that's a bit of a mouthful. So usually we just say paint timing. It's the same concept that we use for first contentful paint or largest contentful paint. We're not really measuring paint in Chromium. We're measuring the presentation time of the frame as best we can. And that's why it's interaction to next paint. It's a concept that's pretty well understood by developers already measuring web vitals. So each interaction can actually have multiple animation frames associated. Typically, that means 2 frames as you sort of key down or pointer down and then lift your finger and you have a key up or pointer up. You'll have multiple animation frames tied to what a user would consider a single interaction. But you can actually even have 3 frames in certain cases, depending on how the events that are registered and how it's implemented. And each page can, of course, have many interactions. And because we'd like INP to become a core web vital, we need a way to summarize everything into a single score. Okay, that's just how vitals work. So for INP, we settled on reporting the single longest interaction. Okay, so that leads to, actually, I'm gonna switch to this frame. There's a nice little transition. So that leads to some ambiguity in the naming of interaction to next paint. Every interaction has a duration, and you could name it its interaction to next paint, while the whole page has an overall score, which you could also call the page's interaction to next paint. It's not really a new problem. LCP has a similar issue. Typically, we say that you have an LCP candidate or a bunch of LCP candidates and then a final LCP score. So I think with INP, we might settle into something like that as well. Every interaction is a candidate for the page's overall INP score. Now, I said that we measure the single longest interaction as the way to score the page, but I sort of simplified. Some pages are super long-lived, very interactive, and sort of if you measure enough times, you'll hit some outlier. A page that is mostly responsive might blip occasionally. So we kind of drop a few outliers. Basically, every 50 interactions, we sort of drop the highest. And so it's kind of the nth highest, or sometimes we call it the 98th percentile, although we're phasing out that wording. It's kind of needlessly confusing. For the most part, most pages, vast majority of pages, the worst interaction is the thing that's measured. All right, hold on, we're loading in here. So this metric, while experimental, is already widely available in the field, and it has been for years. It's even supported in Firefox with only tiny caveats. Many site owners are already using it. We've gotten lots of positive feedback. Folks are already making changes, improvements, bragging about it, which is wonderful to see. Page Speed Insights already shows it in the UI by default. In the bottom middle, you'll see it. So anyone typing in their URL to get sort of crux data or Lighthouse data results, they'll see it front and center. And so it kind of sticks out like a sore thumb. So this is the chromium.org default website, and it's got a beautiful score for desktop. Less so on mobile. Who can guess why we got a 300 millisecond delay from field data on the mobile website? Shout it out.
If anybody wants to shout quickly, let me know.
Yeah, I see Rob smiling. So I think I had a screenshot. I forgot to put it in, but it's the good old fashioned mobile viewport, tap delay. It's been a few years, but we're still doing it. So,
which we've almost gotten rid of.
Yes, exactly. If you'd like to learn more, you can read up on web.dev/INP. But if I was to summarize, I would say interaction to next paint is meant to be a much better input delay, measuring the way a user might describe it. How long does it take to see any feedback at all from interactions? All right, now's the fun part. I'd like to get a hands-on feel for what does it really feel like to measure interactions or responsiveness. So I put up a demo. I will try to cast it. Unfortunately, I couldn't be there with you today. This doesn't always come across so well over VC. So if anybody would like to follow along, here's the link. You could try it later. You could trace it. I'll leave it up for a sec. But this talk was actually this demo was originally done to be presented to real web developers to help teach the concepts of INP. We get a lot of questions. And I know there's broad confusion on a lot of these concepts. And so this is meant to teach. And I actually don't know, for this audience, this might be very intuitive and this might be very easy stuff. And so I'd like to poll the audience. I actually have no idea. Maybe this is very simple. We'll see how it goes. All right, that's enough of that. Hopefully you managed to get it in time. All right, can folks see that? Okay, I'm gonna leave the console up because we'll need it later, but I have a very simple demo on the left. Is it coming across well, first of all?
It comes across okay. Could you bump font sizes?
The left or the console?
Both.
All right, let's see how my CSS does. Don't tell Yin. There's lots of grid here. We'll see if it works. Okay, so this is a very, very, very simple web UI. It's commonly, this type of interactive UI is often used to demonstrate frameworks and how you might do interactive components. The implementation doesn't matter here. Every time I click this button, I have a hover effect or an active effect on the thing just to get across to you, the audience, when I'm interacting. You can see the score updates almost instantly. It feels very responsive to me when I'm using this. But exactly how responsive is this? How would we measure it? So let's add a few metrics to the page. So we have FID, first input delay, which is a classic. We have the new INP. And the first time I interact with this page, I'll see the score. I'm also visualizing the FPS as measured by the page and just a rolling timer. That has nothing to do with responsiveness. It kind of helps you see what I'm feeling as I interact with the page. So it's for you, the audience, to see sort of blips. And this click handler is not going to do very much. It's just going to update that UI. So hopefully, if all goes well, if GBC doesn't slow me down too much, as I interact, everything still feels very nice. First input delay and interaction to next paint are still in the green. I'm actually seeing higher numbers than I would normally without screen casting, but it's still pretty good. We're still in the green. So one difference, hopefully that jumps out immediately, is first input delay is lower than interaction to next paint. INP measures more time, a more end-to-end duration. And so these numbers are larger than you might be used to. Still a very interactive UI. The reason this UI is very interactive is because this page is not doing anything except focusing on this one UI, which is not really what the real world is like, of course. We've got other things going on. One of the most common things you see on the web is during load, a bunch of scripts get loaded, they execute at an arbitrary time, and you get this big, long task, big total blocking time really soon after page load. So let's try that. Oh no, I apologize. First, I wanted to separate out, commonly, when you interact with an element like this, there are actually two components. You've got sort of an initial UI update, and then an eventual UI update. You might hit network, and then when the network fetch is finished, then you'll get some feedback about that. You'll get like a loading spin or something like that. So I simulate that here. I didn't actually do a fetch. I simulate that here with just a set timeout. So I will update the UI initially. There'll be some loading UI and then final thing. So who wants to take a guess? Does INP measure all the way until all of those asynchronous effects are finished or not? Raise your hand if you think it should, and keep your hand down if you think it should not. All right, I'm not seeing any activity. Very good. So as I interact, it takes some time to sort of finish all of the work. In this case, it's hard-coded to be a second, but INP does not measure that time. So that's one of the questions that we get. You know, what happens if I hit the network? INP doesn't measure that time. It just measures the very first visual feedback. What if your event handler does nothing, doesn't update the DOM at all? What if it waits until that network request to come back and then updates the DOM? Should it measure that? Will it? Hands up if you think INP will measure that. No. Okay, good. Thank you, chat. Again, very good. So in this case, the UI, it's kind of janky. It's not a great experience. It's kind of lagging. I don't really get much feedback. But you know, the timer keeps rolling. The FPS remains high. The visual feedback of the button itself, everything is allowed to update. The page isn't sort of sneezing on me. So from the perspective of responsiveness, the page is doing fine. The UX might not be great. The experience might not be perfect, but it's still a responsive site. Okay, so INP does not judge on the quality of the response. It's just judging that it can respond at all. All right, so far so good. All right, so we're gonna revert back to the original version before we move on. So like I was saying, most sites are actually doing something. So let's start adding, so let's start adding. Okay, next demo. So in this version of the demo, 2 seconds after this page loads, you're gonna get a long task. All right, let me refresh again and you'll see that the timer will go up to 2 seconds and then it kind of blocks. Jake Archibald a few years ago had a wonderful presentation about the browser event loop and how it works. And he called these things sneezing. You know, all of a sudden your browser your main thread sneezes. And I love that term. So we know that these types of long tasks definitely affect responsiveness. So what's gonna happen if I refresh the page and try to interact with this button? Is that gonna affect responsiveness? I see head shaking. Yell it out. Who thinks it will? Who thinks it won't?
Yes.
All right. Well, here I go. I interacted. I got a really good score. And I keep interacting, and I still get a really good score. Let me try it again. This time I'm going to wait. And now I'll interact. Nothing's happening. Oh, after some time, then I get penalized. Let me try it again. This time, I interacted before and during. So it's dependent. There's a chance it will affect responsiveness. It depends on when the user interacts. There's this ticking time bomb on the page. But nothing guarantees poor responsiveness unless the user actually interacts. So that's one of the differences between measuring total blocking time on a page versus actually measuring responsiveness. And we find that users will sometimes adjust behavior if they know to expect a certain latency. You know, are you likely to hit Gmail while it's loading? Probably not. You're going to wait for things to settle before you start interacting. So there are measurement effects in the wild with measuring responsiveness. It's a pretty common problem. Okay, so this was a single sort of sneeze after load, which is pretty common on the web. What happens if you have a sort of set interval? You periodically sneeze. There's a bunch of work happening, a bunch of third-party scripts doing random work. Is that going to affect responsiveness as I interact? What do you think, audience? No. Well, if I'm lucky, if I time it carefully, if I look at that timer, I can sit here interacting over and over and it won't affect. But of course we know there's a ticking time bomb. And if I wasn't paying attention to that timer, eventually the bomb goes off, okay? So first input delay only measures the very first input with the page. And so in this case, even though the page is like, it's crazy, it's got this ticking time bomb, you've got a 50-50 chance of actually hitting it. With INP, it trends towards infinity, or it trends toward 100% as users interact. So one phenomenon with INP is that as users interact more with a site, it's more likely to measure these ticking time bombs. Okay, so more interactive sites end up reflecting the true sort of responsiveness of the site. You might get lucky if a user just loads once and just happens to interact. You might get lucky. Okay, so the importance of good responsiveness is kind of dependent on how many interactions users have with the site, if that makes sense. All right, so we've got this work. We can't get rid of it. Okay, it's got to happen somewhere. We like to get it out of the way of interactions. We don't want any of these sneezes. We don't want any of these ticking time bombs. So one useful strategy is just to wait until a user interacts before firing the work, okay? So here I am, I'm gonna update my code. I'm gonna say, I'm gonna wait for the click to actually happen, update the UI, and then do the work, okay? So get out of the way of the interaction, at least get it started, and then I'll sort of update it when it's all done. Does that make sense? It's a common pattern. I mean, it's a pretty good advice. What's gonna happen? Who thinks this will feel responsive? Yes or no? See some head shaking. All right. Terrible. Okay. The click handler fires and it will run all of this work for a second synchronously, blocking the ability to do anything else, blocking the ability to do rendering work, blocking the ability to show result. Every single time. Input delay will always be perfect, but interaction to next paint will always be terrible. And visually, it will always be terrible. So it matches what a user might actually experience. Now, this is incredibly silly. It's way worse than just doing the work at startup and hoping that at least it gets out of the way. But sadly, it happens on the web. There are scripts that get out of the way of interactions by just blocking the interaction, waiting for the worst moment to sneeze. All right, so I know how to fix this. What we really want to do is we want to wait for that click and then do the work after the event handler is finished running, right? So let's do what we did before with the set timeout. We'll start updating the UI and then sort of post a task to do this after the click handler is done. Does that make sense to people? So what do we think? Is this going to work? Come on, folks. Interactive. Last demo of the day. Just guess.
I'm cheating and already doing it, so no, it's not great.
Okay, so it might work on some pages in some situations, but never on this one, or rarely. If you do it enough times, you might get lucky. All right. There's a bit of a race. We're waiting for the next frame to start rendering, but this task isn't waiting long enough. We need to wait for that next frame. So, maybe if I waited 16 milliseconds, like I know frames run at 16 milliseconds on most monitors, maybe it's lower on some. You know what? Let's just wait 50 milliseconds. Let's just throw it out there. Let's just be extra secure and extra safe. We'll run the handler and we'll wait 50 milliseconds and then we'll do the work. Is that going to work? No cheating. Stop cheating.
I'm gonna say no.
We solved it. We solved it. Okay, so now I click, the UI updates, I see some loading indicator, and then I get a sneeze. The sneeze is still there, but it's okay. It's happening after the interaction, which is perfect. This is what I was in for. So responsiveness is now fixed. But it really gulls me that there's a hard-coded 50 in there, right? What I wanted to do was I wanted to wait for the interaction and then let it get to the next frame. Well, there's an API for that, isn't it? Right? Request animation frame. So is that going to work? Yes or no?
Yeah, you gotta double buffer that one.
You got a double buffer. Very good. It's not going to work. It does wait for the next frame, but it blocks the frame. much like doing the work in the click handler, doing it in the frame rendering path is the worst time to sneeze. All right, so let's merge approaches. Let's merge that set timeout to post a task with the request animation frame. And now, just as before, without the magic 50, we're always doing the work after the frame. All right. Sometimes folks will just double wrap. They'll wait for 2 request animation frames. There are some advantages, some disadvantages, but this is similar. You want to wait until after the next frame. Cool. All right. So we're still sneezing, but we're doing it in a controlled fashion. Ahmed, it picks the worst one. So as many times as you interact, it'll always focus on the worst one with some caveats. And then here, this is very similar to the previous demo, but instead of using a request animation frame with set timeout, it comes out that request idle callback does the same thing. When you post, when you use request idle callback, you'll wait for after the next frame. Now, Scott Paisley helped me realize that this is not strictly guaranteed, but it's effectively close. If this doesn't work for you, there's some implications to using request idle callback. You could stick to the previous pattern, but for this demo from here on in, I'm going to just use this API because it's one indentation less. Still works. All right, so click, feedback, sneeze. Click, feedback, sneeze every single time. However, as some of you have started grumbling about, if I start interacting more often, you might not be able to see this, but I can. Things just get worse and worse and worse. I've delayed the sneeze until after an interaction, but the sneeze is still a sneeze, and it will be a problem for the next future interaction. Okay? So moving the work around helped a little in certain cases, but it still sort of blocks the whole UI. There's still a repercussion to sneezing, and if you interact more than once, which is very common on a lot of applications, you'll just get burned eventually. So how do we get rid of the sneeze in the first place? Okay, we got to do this work, but we need it to not be so blocky. We need it to be a bit more yieldy. Well, let's take a look at what I'm actually doing. So in this case, I'm, kind of emulating what might actually be happening in the wild. I'm creating a bunch of tasks, and I'm looping over and running each task. You can imagine that this is calling a function that calls another function that calls another function, and sort of split all the work down. This sort of looks nicer, but you might have a whole tree of different code that you're running. And you can, given how nicely I've chunked this up into simple tasks, you might think to reach for a task scheduler or use the new post task API, which are definitely wonderful solutions. But it's not always so easy. If you just have a bunch of code that is like a bunch of blocking synchronous code, a better strategy is to sort of sprinkle yield points. There's a new proposed API called scheduler.yield, and it's been pretty exciting to see it coming, and there's some polyfills making the rounds and folks are starting to use it. So what does that look like? So inside of this worker function, I'm going to polyfill scheduler.yield, which will basically allow other work to be intertwined with this. So I'm going to yield out of the loop that I have going here. I'll let other work, like other interactions, like other rendering work, actually make progress. And then it will resume and I'll continue doing my work. So I'm being very nice and I'm sharing the main thread if I do something like this. This tends to be an easier pattern to adopt. This isn't a feature that's launched yet, but it's intent to prototype. All right, so what does that look like? Okay, so if I click once, it's not sneezing anymore. FPS is still reasonably high. The timer is still rolling. And if I interact multiple times, FPS takes a bit of a dip, but it's still doing pretty darn well. The timer's still running and the UI updates pretty frequently. And then the work continues. All right, so we've arrived at perfection. In terms of best bang for buck, this is where you can settle. This is, you're done. I do think there's like a tiny little change you can make. So previously I was still calling request idle callback, and then I was yielding after the first task. But if you just flip the order, you can kind of simplify things. You don't really have to request idle callback as long as you yield right away, if that makes sense. So very, very responsive UI, and it allows anything else on the page to make progress. All right. So again, best bang for buck for developers. This is the pattern that's worth learning. And as scheduler.yield becomes a platform primitive, it will actually have even better behavior out of the box. However, there's a problem with this implementation because it's a polyfill. The problem is that we're yielding to anything. And that means that if we're only yielding to new inputs or to rendering work, everything is wonderful and very responsive. But if there's any other script on the site that is not well behaved, it can get in the way. All right, so we're being too nice. And I could kind of simulate that by just interacting a whole bunch of times. Where before, I would have run the first interaction, finished it, and updated the UI. Then the second interaction, finished it, and updated the UI. Now, all of those tasks are basically saying, okay, would you like a turn? Here, now after you, now after you. Everybody's being super polite and sharing the main thread, which is what we want. But it means everyone is delayed, or all of these tasks are delayed. Does that make sense? It's a tragedy of the commons.
Wow.
So common strategy that is trending on the web. Oh yes, I'm going to skip over benchmarking to prove this to you because hopefully it's evident in the UI. So a common strategy out there is to only yield if there's actually input pending. Okay, there's this API for his input pending. So you're going to hold on to that main thread and you're going to run to completion. You'll run a bit faster. There's no overhead of scheduling. There is also no risk of a long task slipping in and preventing you from completing your work. So is this going to feel better? Unfortunately, we've slipped a bug back in, and this is pretty common. From our click handler, we call this work, and this work is trying to be nice and yield whenever there's input pending. But it comes out, is input pending is not true in the context of event handlers. So we're in the middle of a click. An event is no longer pending. It's already been dispatched. So it's a little bit too late. You know that this is the most important time and you're calling a long blocking function. And this function doesn't know that it should be friendly. All right, simple enough. We'll just reintroduce that request idle callback. All right. So from the context of a click handler, we know input's pending. We don't want to start this work. And once this work gets started, which will come after the next animation frame, it's going to be really nice and share with new inputs that arrive later. So if I click, it'll happen right away. If I click multiple times, it'll yield. Really good. All right, so for the most part, this resolves the biggest issue with is input pending, which resolves the biggest issue with calling scheduler.yield, which is implemented using a polyfill, which is not as smart as the browser primitive that we'll get, okay? But there's a potential time bomb here too. So whenever I call do some work, which happens after every click, we get out of the way of the current input event. But all of these are running in a tight loop saying, if there's no input pending, I'm not going to yield. I'm going to keep running tasks. So the more I click, the more of these are running, not in parallel, but at the same time. And if any of these gets scheduled between the event handler and the next begin mainframe call, it's going to run forever, or at least until it's done all its work. Now, Scott's actually improved Chromium quite a bit a few months ago, where we are way more likely to run rendering. But still, we have to request a mainframe update and get it scheduled and get it to run. There's a race condition there, which is likely to be run by rendering work. But on my Android device, rendering loses, not infrequently. And so there's another sort of ticking time bomb here, where if any of these ends up scheduled first, it's going to run to completion and you'll get a much larger IMP. Okay, so the way to resolve that if you want to go there, is mark frames that need to wait till next paint. So instead of just using the browser primitive of is input pending, also mark there was an interaction, we need a UI update, and all you folks here are going to check that state, and you're going to elect to not run until after the next animation frame. All right. I didn't show all of the polyfill here. We could take a look at the code later, but now it's just as good as before, but it sort of never ever jinx. And then finally, a very common strategy is to just hedge your bets by adding deadlines. And that tends to work relatively well in practice. There's a trade-off between overly sharing and sort of making mistakes and get running on infinite loop. And that's it. We're done. No more demos. It certainly gets pretty darn complicated, but it's good to think about when these things run. There's a whole bunch of things that can happen in rendering in the real world. And I await scheduler.yield implemented by the web platform, which will just solve all these problems. And you can just use the platform. And I think that's it. That's all I had. Any questions?
Before anyone else goes, I'm going to use my prerogative to ask a question. As much as I appreciate a 38-letter long method, what is that actually called in the real API?
This one?
Yeah.
So this is just called scheduler.yield. I created one. Let me see if I will make this larger. So scheduler.yield if needed with deadlines. So I don't know if we want to think, but basically, if we know input is pending, we mark that we need an X paint. And if we need an X paint, you sort of wait until after the next animation frame. Or if you need to yield because of deadline. And it's just a bunch of conventions, basically a bunch of best practices. There are a whole bunch of userland task schedulers that do different things that are more clever, framework specific, that sort of thing. At the end of the day, I forgot which demo it was. I think it might be 12. Anyway, the one that I showed, this will just look like scheduler.yield. Here's the intent to prototype from Scott. This is what you want. You just add these everywhere, sprinkle them between every function, and hope for the best.
All right. All right. Any other questions? Yes, got one in the audience.
Do you have any opinions about request post animation frame, which is a kind of old proposal that I haven't heard much about in a while, but basically what it does is work immediately after paint. Yeah,
so this is this RPAF, request post animation frame, or a polyfill of it. I use it all the time. I try to polyfill it, but the actual request post animation frame would be slotted in basically inside the rendering task, just like request animation frame is inside the rendering task. It would just happen at the end. So you would be guaranteed to run even earlier, as opposed to what I do, which is request animation frame, then post a task, a macro task, and hope for the best. So I certainly use it, although I use it to polyfill a bunch of scheduling APIs that are actually landing as first-class primitives. So I would probably defer to Scott to answer the question, will this still be needed after it all launches? But yes, like the strategy of calling request idle callback to make sure whatever work you call gets out of the way, basically delay the sneeze, the perfect API would have probably been request post animation frame. All right. I guess that's it. Thank you very much.